Guys, we are back with our video on Hooke's law, and we are back with the same Java applet that we were using. So earlier we found out that there were three springs that you can see here, 1, 2 and 3, and we found out that first of all the springs are made of the same material, yes. And all of them have a stiffness of 1 over 0.09, which I just found a calculator here, and if you can see, the 1 divided by 0.09 gives me 11.11 newtons per meter. So this is my stiffness that I calculated in the earlier video for all of these springs. Now let's see, since we know the stiffness, we will find out first of all the extension when a known mass is applied, and in the second example we'll find out is looking at the extension and the mass of an unknown substance, or unknown let's say a material. So let's see, first of all, let me just put it here. So let's put it here. This is my initial thing. Yes. So this is my initial thing. So you can see, let me just place it properly. You can see that this is 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. This is, let's say, let's just place it here. Alright, on the 30th mark. Alright. So this becomes easier for us. Okay, we know the stiffness constant. Wherever we place this ruler, it doesn't matter because the change will be the same. Alright, so initially it's on the 30th mark. If I just place it correctly, yes, this is the 30th mark. Alright, now I am putting a mass of, let's say, 50 grams on this. So the mass that I'm using is 50 grams, which we will always need to convert this into kilograms. So this is 50 grams would be 0.05 kilograms. Why? Because we divided by 1,000 to convert it to kilograms. Alright, so this mass is 0.05 kilograms. Now let's find out the gravitational force that it will be, because you know that if this is the spring and this is the mass attached to it, the only force that this mass would have on this spring would be the downward force because of this mass, which is known as the gravitational force or weight. So we know how to calculate weight, which is mass times gravitational acceleration. So the mass in kilograms is 0.05 kilograms times the gravitational acceleration, which is 10, approximately 10. So the weight becomes 0.5 newtons. Alright, this is the force that is exerted on the spring. This is the force. Now we know the stiffness of this spring that we calculated in the previous video, which is, I just showed you, 11.1 newtons per meter. Right? Let's find out the extension of the spring. So we know our formula of Hooke's law, which is F is equals to K times E. And if I make extension the subject, this would become E is equals to F times K. The force that is applied by this mass is 0.5 newtons. And the extension and the stiffness of the spring is 11.11 newtons per meter. So if I divide this by this, my answer would be in meters, obviously, because all of the units are either newtons or meters. So my answer would be in meters. So let's use our calculator here. So now it's 0.5 divided by 11.11. This would give me 0.045 meters. which if I multiply by 100 to convert it into centimeters, because my scale is in centimeters, so I will have to multiply this by 100. So if I multiply 0.045 by 100, you can see my answer would be 4.5 centimeter. So my extension is 0.05 meters, 0.45 meters, or 4.5 centimeters. So whatever the original length is, it will extend to, let's say, it will go on for about 4.5 centimeters down. Right? It will, let's say, if the original length is 30, the final length would be 30 plus 4.5. This would be 34.5 on the scale. So let's see if physics is actually working. Let me apply it here. Just right here. This is 30, alright, is here. And this is 30, 31, 32, 33, 34, and this is 30. As you can see, it's exactly in between the 34 and 35. So we can take it as 34.5. So you see that our calculations are working. Physics is actually working. So this is our first example. Now our second example. Okay, I'm sorry. Our second example, we would be taking an unknown mass. Alright, the colored ones here, they're unknown, right? So we will be taking an unknown mass, and we will, by looking at the extension that it provides on a spring and its stiffness, we'll find out what this mass is. So first of all, let me take this mass. Alright, it is somewhere between 100 and 250. You can see the size, so it's somewhere between that. So let me just put it here. The original mark is at 30. Let's find out the extension. Remember that the new length is not our concern. The extension is our concern. So you can see it is somewhere here. So this is 40, 41, 42, 43, 44, 45. So it is at 45. So the extension, the original length, the original mark was 30 centimeters. The original length. The final length would be 45 centimeters. So the extension is simply given by 45 minus 30, which is 15 centimeters. So it extended to 15 centimeters because of this mass. However, we don't know the force that it is exerting, because we don't know the mass of this body. So we'll have to find that out. But on the other hand, we know the extension and also the stiffness of the spring, which is 11.11 newtons per meter. So our formula is force is equals to K times extension. Let's find out the force first that this mass is exerting. We know the extension. Let's convert this to meters. So for meters, we will have to divide this by 100. So this would become 0.15 meters. So force is equals to K, which is 11.11 times 0.15. Our force in newtons would be, let's use our calculator here, 11.11 times 0.15. This would give me 1.665 newtons. However, this is the force, the gravitational force, because of that mass. But we have to find out the mass of that object. So we know our formula to find, when we know the gravitational force, to find the mass, we can simply use this formula. So gravitational force is 1.665 equals to mass times 10. So mass would be 1.665 divided by 10. This would give me 0.1665 kilograms. This is the mass in kilograms. Or if I want to convert this into grams, just simply multiply this by 1,000, and you would see the mass in grams would be 166.5 grams. And you can see we predicted that it is somewhere in between 100 and 250. So we are pretty much right. The mass in grams is about 166.5 grams, and it gives us an extension of 15 centimeters. So we can work both ways. Either if you know the extension, you can find out the mass that is producing that extension. If you know the mass, you can find out the extension that it will produce. Remember, the only thing that you need to find out earlier in your scenario is using a known mass, find the extension, and then eventually find out the stiffness of the spring. Once you know the stiffness of the spring, you can calculate anything about that object. So guys, that would be it for this video. In the next video, we'll be doing some more examples, and we'll be learning about something different in the next video. So stay tuned to it, and thanks for watching, guys.